How are you, everybody who is watching this fantastic video? I'm very happy to have you, and I'd like to take this opportunity to welcome you into the moment of learning the beauty of electronics and telecommunication engineering. My name is Olenjolain. I love so much electronics, and I like so much electronics and telecommunication. I don't know about you. I think that even yourself, because you've been engaged with this context, you love it. So today, I will be teaching you about how we can solve a real-life engineering or electronics engineering problem. So I have some local students who will be just a part of this class. Before I do the quick review, I would like to welcome you online. And in case you have any questions, don't hesitate to prepare the question, because I like questions more than teaching. I believe that. And one thing which I want to tell you, whether you are online student or offline student, Olenjolain does not know everything about electronics and telecommunication engineering. I just know a small portion, but I have a strong desire to learn this stuff for the rest of my life. And I believe that. I trust in God. I think that even in my next generation, possibly one of my child will continue this business when I've been away from this world. So that's what I trust in. So one thing which I want to tell you that I just know a small portion of it, and I'm always responsible to teach others about what I know. So remember that Olenjolain does not know everything about electronics and telecommunication engineering. There are some people who knows much more than what I know. So I have nothing else to proud myself or make to boast myself. But one thing that I'm doing my responsibility, I'm doing my purpose to be born in the beautiful country of Tanzania. So if that's the case, I don't want to waste much of your time. I want to take you into today's business. So let me just introduce the offline or the local students who are undergraduate engineering students in electronics and telecommunication in one of the institutions that called Dar es Salaam Institute of Technology. Good morning, class.
Good morning, sir.
Again, good morning, class.
Good morning, sir.
Do you like electronics and telecommunication engineering?
Yes.
Are you ready to learn it?
Yes.
Well, so let us start our business. So before I take you into today's workshop, which is workshop 2, let me do the quick review. Yes, use this space to do the quick review of what we've covered in workshop 1. So WRK, this is workshop 1. So simply in workshop 1, I just told you that engineering and engineering field can be summarized in 5 terminologies. The first one, we say that engineering can be described, or engineering fields can be described in terms of number. Students, in terms of what? Formula and what? And the mathematical equation. It can be also described or represented in terms of diagrams. We have electronics diagrams. And also it can be represented in terms of table. And this we call the table of results from experimental. And also it can be represented in terms of what? Of graphs. And I told you that this concept or these 5 keywords of engineering, we have been introduced since standard 3. Since standard 3 in primary education. In Swahili we call it since darasa la 3, when we began to learn about science. So it's not a new phenomena, but maybe you have never think about that. Then I tried to, I presented to you about how do we transform scientific, we call it scientific experiment into engineering experimental information. And for this case, I just used the table of results in scientific experiments, and also I showed you the corresponding table of results in electronics and telecommunication engineering, right? I told you that in case of table results that we had in science, mostly we just have experimental column. So if we are dealing with resistor, you have to measure and then you represent. So if this is all about resistor, this is about current, this is about voltage. But in case of the table of results for engineering, especially electronics engineering, every electrical parameter should be represented in 3 ways. That we say in case of resistance, we should have a theoretical resistor. And then also we should have, for instance, that we call this simulated resistance of the resistor. Then we say that another column will be practicality practical or the experimental measurements of resistance of the resistor, right? So it means that in engineering, especially electronics, the real electronics engineering, we transform what we've been learning in science, but we have to add the value. So in science, we are just filling this said column. But in engineering, we have to grasp the concepts of the theory and the concepts of the simulation, which we introduce you when you engage yourself in electronics and telecommunication or in the field of engineering. Are we together, class? Then, next, I told you about algorithm. Algorithm of what? Of solving a real life engineering problem. Right? Right? Then the first thing, we say you have to identify a problem. Right? Then once you have identified the problems, you have to propose the solution. Right? Then, once you propose the solution, you have to represent your proposed solution by using diagrams. By using what? Diagrams. By using diagrams. And in case of electronics and telecommunication, we have mainly 3 fundamental diagrams. Right? The first one, we call it what? General block diagram. Right? So when you open these general block diagrams, then we get another block diagram, which we call the detailed block diagram. Are we together? Then, once we have this one, we say that now we find that we have to engage something we call the design to come up with systematic circuit diagram. Are we together? Once you have schematic circuit diagram, it means that in design, this is the moment or this is the part where we can fill the first column of theoretical calculated values. Right? And then once you have a schematic circuit diagram, we can draw these schematic circuit diagrams by using what? Electronics simulation software. Okay? So then the next part is simulation. So when you draw there, the intention is not to draw. The intention is to test the circuit by doing the measurements. Okay? Okay? So when you do measurements, we have or we'll fill this table or this column of simulated values. And I will show you. I will teach you. Are we together? So after we have simulations, then we say we are going for what? Testing. Hardware. Hardware. Implementation. So hardware implementation, it means that when we implemented the proposed solution, the schematic circuit diagram, okay, then we can do measurements. When we do the measurements, we can fill the said column of practical results or experimental results. Are we together? And when I told you about this concept, I told you that sometimes, in case you go for hardware implementation of the particular system, there is no need of a teacher to come to confirm about your results. Because you know the theoretical or calculated results, you know the simulated results, so you have to know that if the hardware implementation or the practical results deviate more from this one and this one, so then you can have to know yourself that possibly you are not correct. Are we together? But in Bongoland, we need a teacher to come and see the measurement. Why? Because students are expected to get a confirmation from the teacher. And I want to tell you that that is wrong. That is wrong. And I gave you a simple example. When we are doing the experiments of the experiment of mechanics, you are just finding or determining the acceleration with gravity, right? You know it's always 9.0. Before your father is being born, it is 9.8. When we are born, 9.8. Even if I die today, acceleration gravity is still what? 9.8. In case you find that the acceleration gravity, when you do experiment of simple pendulum, right? Simple or compound pendulum, and then you find the acceleration with gravity is 20 meters per second square. Do you need somebody to tell you that you are wrong? Huh? The similar scenario for electronics and telecommunication engineering. Are we together? So when you have audio implementation, the next part is what? Testing. Then conclusion. Okay. So yesterday, I told you about the problem statement. where we say that it has been observed that the audio signal attenuates when it has been transmitted into the over long what? Distance. Then we say what is our proposed solution to design what? An amplifier to boost what? The signal in order to be transmitted what? Long distance, right? Then we discuss about general block diagrams. Did we discuss about that? So we are done with this, we are done with this, we are done with this part. Okay? Then we come forward to detailed block diagrams. That's the point where we ended yesterday. And we began to discuss, or I began to teach you about detailed block diagram of what is power supply unit. And then our final drawing was this one. Okay? Okay? So how many blocks do you have? 4. Which block did you open from the detailed block diagram? Linear power supply unit. That the block, it was a single block, but now we have 4 blocks within it. Are we together? Yes. And then this is the point where we ended yesterday. So let me continue from where we ended. And we discussed a lot of stuff and regulated the signal, and my student whose name is Pili was a little bit confused and neglected. The challenge of the students, they used to be satisfied when they have a little knowledge. When I mentioned that we are going to use a linear power supply, you know what did you say in your mind? I know it. Especially in Bongo. I know nothing new. I know it. I know it theoretically and practically. So it means you block a new knowledge. But I want to tell you that nobody knows everything. And nobody knows even the future innovation. That's why that innovators and engineers, they never stop innovating. Because you can be satisfied with linear power supply, but still has so many challenges. If you learn through or around, you can discover something. Are we together? So we just opened one block. So today, so if that's a quick review, and so where is the duster? So the duster still this one. You didn't find the duster. Joanna, go and find the duster now in the other classes. You are sitting in front and then you don't find the duster for your teacher. That is Joanna. So this is simply about a quick review. I cannot go into too much details. We still have a workshop 1. Don't worry, you have not missed anything. We recorded the video, you missed the text and the audio. Missed the voice. You didn't miss anything. So in case you forgot the previous material, review them. Okay. So today it's workshop 2. Tell your neighbor today it's workshop 2. So ask your neighbor, are you ready for workshop 2? Okay. So this is workshop 2. You see, Johanna knew where the duster is, but he doesn't care. So the workshop 2 today will be keep on focusing about what? Okay, so we still about designing of an audio amplifier. An audio amplifier. So let us continue where we ended yesterday. So refer our detailed block diagram. Refer. When I say refer, you have to go back. Refer the detailed block diagrams of our audio amplifier. Are you there? Yeah. How many blocks do you have? 3 blocks. 4 blocks, right? One of the blocks is called what? Linear power supply unit. So we have opened this block, right? Another block is what? Input unit. No, we call it what? Microphone. The next block is called what? Amplifier, audio amplifier. The other block is called what? Speaker, or we call it load. So speaker there, we can write speaker or we can write load. Not load of this way, not load of this way. We means, not load of, with R, so we means about this one. Okay, so if that's the case, we still have to go in details. We cannot, it means that the block of microphone is, it's only one. So we have to go and open another block that we call the audio amplifier. Audio? Audio? Okay, so this is 5 point what? 5 volt. 2? 5.2. So 5.2 now, let us open the block of audio amplifier. Audio amplifier. What are you discussing? Audio amplifier. So we had a single block. But the single block, we have different types of audio amplifier. But mainly we have two. Fixed bias amplifier or fixed bias small signal amplifier and the voltage divider amplifier. So whether it is fixed or whether it is voltage divider, the block diagrams of the audio amplifier will be the same. You listen, what am I telling you? We say that in electronics and the telecommunication, we can build the audio amplifier, or we call it a small signal amplifier, by using the common emitter or CE configuration. So you say that the biasing voltage, the biasing voltage may be set in two ways. May be set by using something we call the fixed bias amplifier and the voltage divider amplifier. Voltage divider amplifier. So you see that the common configuration of audio amplifier is voltage divider. Divider amplifier. Voltage divider audio amplifier. So we can design the audio amplifier separating. We can design the audio amplifier by using the fixed bias configuration. Say fixed bias configuration. Or we can use the voltage divider configuration. The difference between the fixed bias configuration or the fixed bias small signal amplifier and the voltage divider small signal amplifier is just the number, or it's just the components which are used to set the biasing voltage, which we call T VB, or the base voltage in case of small signal amplifier, or in case of bipolar junction transistor. Are we together? So this is the common one. The common is voltage divider amplifier. This is the common configuration, and that's what I'm going to teach you. But you can also implement the voltage, the audio amplifier by using the fixed bias amplifier. But remember that in electronics, especially for the case of the bipolar junction transistor, we have three types of configuration. We have common emitter configuration, we have common base configuration, we have common collector. Common collector? So common emitter configuration, it means that the emitter terminal is common to both input and the output. For the common base, means base is common to both input and output. For the common collector, it means collector is common to both input and output. Are we together? Are we together? So we are using the common emitter configuration in case of bipolar junction transistor. If it is, or if you want to implement the audio amplifier by using the field effect transistor of 8, you have to use, because in case of field effective transistor, we have also 3 types of 40 configuration. We have the configuration called the common source. Say common source. Say common source. Common source is corresponding with common emitter. Then we have also a configuration that we call the common drain. Say common drain. Common drain is corresponding with what? Common collector in bipolar junction transistor. And also, what are you doing? And also we have what? Common gate. Common what? Common gate corresponding with common base configuration. So for this case, because we want to be more specific, I'm going to teach you how to solve this problem by using bipolar junction transistor, which you are familiar. I don't think that if you are competent enough in field effect transistor or in MOSFET. So because maybe you need to gather some knowledge about them. That's why that I say, let me teach you by using some of the semiconductor devices which you are familiar. Are we together? Do you have any question? Eh? Eh? Okay. So if that's the case, now I'm going to draw the detailed block diagram of 40. Audio. Eh? Do you like audio amplifier? When are you going to build it? Students, when are you going to build your audio amplifier? Eh? Pardon? My local students, more than 70, they are quiet. The detailed block diagram. Tell your neighbor, this is the beauty of electronics. Tell your neighbor, this is the beauty of electronics. Engineering. The detailed block diagram of audio amplifier. Can you observe your neighbor if he or she is happy with this stuff or unhappy? So the detailed block diagram of audio amplifier. So, stop writing. Understanding is important more than writing. I told you that for those students who come from A-level, you learned audio amplifier 3 years ago when we are in Form 5. But up to this moment, you know yourself that how far you are. And the goodness of electronics, sometimes, the flow of electric current is not like electric circuit. If the flow of electric current, you want to examine the flow of DC current, in case of semiconductors, it's a little bit challenging. Because you can find that you are confused. In case of electrical, maybe you have resistor, capacitor, inductor, transformer. It's simple to predict the direction. Right? But for semiconductor, you have to understand what is going on there. Okay? Are we together? Check the audio. So, We have the input of the audio amplifier, which will be compatible with the output of the microphone. Okay? So once the microphone supply the electric signal, the electric audio signal, according to Eliakim, then I say don't draw, don't write, don't write. Stop writing and drawing. Look on the blackboard. If you are short and you sat at the back, stand up. Especially Matatu there. Stand up to see what is going on. If you are short and you sat at the back, you are allowed to stand up. So listen, we have a block of microphone on this side, right? Eh? The microphone receives what? Mechanical audio signal from the speaker or from the human being. Okay? Then convey it into what? Electrical audio signal. So when that electrical audio signal is supplied to the audio amplifier, the first block that will be receiving the input will be something called the input coupling unit or input coupling unit. So this is the block. Input coupling what? Unit. And then once this one performs its task, then we are going to find another block here. I think that, let me budget the space because I want to draw with the same scenario of what we are going to draw in schematic. So here we have what? Input what? Coupling or coupling? According to what? British English or American English? Or Tanzanian English? Then the next block is this. The next block, we call it voltage or fixed bias unit. Voltage divider unit. Remember that this is the detailed block diagrams of voltage divider. Please examine your neighbor, not to write anything or to draw anything, and not to chat. Love your neighbor as how you love your what? Your soul. Do you know that scripture? Love your neighbor as how you love what? Your soul. So ask your neighbor, do you love me as how you love your soul? What did he or she say? She's not sure. So the detailed block diagrams of voltage divider audio amplifier. So the next block here, we call it voltage divider unit. Then, here we are. The next block here, we say that it is bipolar junction transistor unit. Bipolar junction transistor. Honorable Christina is at the entrance door. Honorable, what time she's arrived? She has arrived? Almost 10, Okay, she tells me that, sir, you know my situation, but you have to try to manage. That's the indication that you are an adult person. Get it? Okay, so then another unit is called what? Bipolar junction transistor. Please look here. You are looking for Christina. Then, the next block is this one. The next block, we call it, this simply just we call it, collector resistor unit. Collector resistor unit. And then another block. Look, Brighton. Brighton is drawing. He said that, oh, I sat at the angle, so I cannot see me. So let me draw. Then the next block, we call it bypass unit. Okay? Eh? Then the next block, we are just opening one block. We're just opening one block, which we call the audio amplifier unit. Then the next block, we call it output what? Output coupling unit. Okay? Okay? Huh? So this one, I think that, let me just see. Here we have a very important unit, which we call the emitter resistor unit. And then here we have what? Bypass. Bypass what? Bypass unit. Or bypassing unit. So how many blocks we have there? 6. Huh? Even counting is a problem for you. Higher. So then we are going to draw the flow of electric signal from one block to another block. Mwatatu, you are doing mwatatu. Not mwatatu, the next year after mwatatu. She's doing something like herself. I said, please examine your neighbor. Because your neighbor, later on, she might be our minister. Or our prime minister. So you'll have, or you'll add up in a status, my classmate become what? A minister of the government of Tanzania. So the input decoupling unit is actual connected or providing the output signal to the voltage divider unit. Okay? Eh? Then the voltage divider unit allow that signal from itself, or which is actually it has processed itself in a compound with a signal which has been supplied to the bipolar junction. This is BJT, bipolar junction transistor unit. Okay? Then the collector resistor also provides a signal to the bipolar junction transistor. Okay? Okay? The bipolar junction transistor unit provide the electrical information signal to the emitter resistor unit. Okay? The bipolar junction transistor also provided the signal to the bypassing unit. This is information signal. And then also the bipolar junction transistor unit provide the signal to the output coupling unit. All of these are information signal. Information what? Or simply call them data signal. Data signal. Data signal. Data signal. Data signal. Check your neighbor. Some of your neighbors are slumbering, are sleeping. So check them. They are watching, but unfortunately they don't see what I'm drawing and what I'm writing. But it's not their intention. They found the accidental. Are we together? Eh? So this is figure what? Figure what, class? Eh? Figure 4. That is what? The detailed block diagram of 40. Voltage divider. Voltage divider. Audio amplifier. So the next question before you draw, how does the detailed block diagram work? You don't ask those questions. For you, you know that we have a kind of very interesting generation which we call them don't care. When you tell them, this day, this is what? This is the schematic circuit diagram of oscillator. Okay, sir. They don't bother. That is oscillator. Okay. They will never ask you how does it work. They will never ask you that where can I use it. It's none of their business. One question which they will ask you, how questions will be asked in exam. Give us tips. Coverage area, concentration areas. And I want to tell you that we have infinite number of Tanzanians who are in such mode. So the next question, if you do remember that what I tested you, once you draw your detailed block diagram, I asked you a question. Explain briefly, how does the detailed block diagram work? Use at most a particular number of words. For you, you said, I have never seen questions like this in my life. That's the first thing that you notice. It's not that how can I use the intelligence and the knowledge that I have to answer the question. And you know so many schematics like that. I say it's not a time for drawing. Now it's a time for counseling. I'm counseling you who you have a infinite number of drawings and they don't help you. So the next question, how does this detailed block diagrams of 40 of the audio or voltage divider audio amplifier work? Yesterday when I drew the detailed block diagrams of the linear power supply, I told you how does it work. Right? But for you, even if I skip that, I don't explain how does it work, you don't care. It's your nature. Since primary school, secondary school, there is no such kind of the question. Then we have another honorable student, engineering students, whose name is called Nation. So Nation want to enter the class now. So Nation, you are welcome. It's usual for you. You are welcome. First of all, congratulations for coming. You are welcome. Yes, congratulations for coming.
Thank you, sir.
Then there is a school behind. Yes, those are the Tanzanian electronics and telecommunication engineers. We expect them to solve what? Problems. While themselves they are causing what? Problem. Which problem are they causing? They are coming to class late. Hey. Sit there. Hey, Shukuru. Okay, so this is how, do you see Brighton? I said it, not in the students allowed to draw, but Brighton has something which we call it is disturbing him, not just drawing quickly. Okay, so this is how these block diagrams work. First of all, the block diagrams that we have there, which we call it the detailed block diagrams of voltage divider of audio amplifier, or voltage divider audio amplifier, it has two blocks. It has two blocks within. The first block dealing with biasing of the transistor. Then another set of blocks dealing with amplifying the alternating voltage signal. You are allowed to write those notes. You can take a note. Can I repeat? I say, these detailed block diagrams of audio amplifier consist two sub-block diagrams within it. The first one, the first unit or the first part of this detailed block diagrams of the audio amplifier, we call it biasing or DC biasing circuit or DC biasing unit. And the second one, it's a part which dealing with amplification and even separating the DC signal and the AC signal. So that's why I told you that audio amplifier or voltage divider has so many information to learn more than you think. Let me repeat. Here is the point. We are using a bipolar junction transistor. Right? Right? Stop writing. Just listen because you know this material. But you just forgot. We are using bipolar junction what? Transistor. What are the applications of bipolar junction transistor? And any bipolar junction transistor can be used, whether NPN or PNP, can be used as an amplifier. Or it can be used to amplify electric signal. Right? Also, a bipolar junction transistor can be used as a switch, which we call the electronic switch. Okay? The said applications of bipolar junction transistor, which I know that many students, they are not familiar with it. Also, a bipolar junction transistor can be used as an oscillator. So how can you differentiate them? I think, did you write here? Have you written here? So that I can explain a little bit, because you used to write and drawing, but you have never bothered yourself to understand those stuff. So listen, let me open your mind. So tell your neighbor, open your mind, open your mind, open your mind. Tell your neighbor. Tell your neighbor. So simply say that bipolar junction transistor can be used as an amplifier, can be used as what? As a switch, can be used as an oscillator. In advanced level, we used to teach students about the use of bipolar junction transistor as an amplifier more than using a transistor as a switch. Are we together? So what the difference? How can you distinguish? It means if I have two N22222 by NPN, NPN transistor, bipolar junction transistor. This transistor, I may use it as an amplifier, I may use it also as a switch. Right? But not simultaneously. So how can I set this amplifier to be used as a switch and be used as an amplifier? No, how can I set this 2N2222 NPN bipolar junction transistor as an amplifier? And how can I set it to be used or to work as a switch? Kevin, you are talking to Mexina. So here it's the deal. We taught you since you are advanced level, for those who have gone for advanced level. For those who have gone for ordinary diploma, we taught you this in basic electronics. Wewe! Mwangalie macho yako. Unafanya nini? T-shirt nyeupe. Ndio maana watu wanaokaga nyuma siku zote hawafuati maelekezo, anaendelea tena. Alafu anacheka, anashikashika macho. So here we have something very interesting, which we call the load line. We taught you in the A level. I'm also teaching advanced electronics science, and sometimes whenever I teach, I don't want to finish. So I can create even 50 videos or lectures of just advanced electronic science, because I know what I was failing to understand during my A-level education. For you, you are understanding. I'm not talking about you. You are understanding everything, right? But for me, I got a lot of troubles. So we have something called the load line. Say load line. Load line for the NPN transistor we used to draw as a collector current versus voltage across collector AB. And then once we draw that load lines, we are drawing something interesting. For me, I like them. We are drawing some lines like this, which is experimental. You didn't take your time to think, what does this line mean? And even when you come to DIT to learn about electronics and telecommunication engineering, you have never thought that I want to understand this graph. How can I obtain? How can I get this graph? You didn't take care about that. You just came, you paid tuition fee, and then you are waiting for the miracles. Right? If you do remember that, here we are writing something called the base current is equal to 0 microampere. Here base currents you can find that is 1 or it's 10 microampere. And here it is 20 microampere. And here it is 30 microampere. And here it is 40 microampere. Brighton, what are you doing? Concentrate here. So this is base current, this is voltage across collector emitter, this is collector current. Keep quiet. Keep quiet. And here we have 0. Then we used to draw something called the load line. Okay? Okay? We use So, I was explaining to you about the aim of this graph. I wanted to open your eyes, stop writing, stop drawing. I want you to open your eyes to see that those 7 blocks consist of 2 blocks, or consist of 2 parts. We have a DC biasing circuit, and we have also an amplifying circuit. So before I teach you this new stuff, Omolo is communicating, Omolo there, is making noise. Before I tell you about how does this block diagrams operate, let me remind you some key concepts that you have heard in your life. Possibly you heard it, but you have never understood. But I'll try my level best to summarize in order for you to understand. So I can draw you to understand how these detailed block diagrams of voltage divider audio amplifier work. Angelina, you are still drawing. So let us come here, right? We say that this one, we call it saturation region. Say saturation region. And this one, we call it cutoff region. Say cutoff region. And this one, we call it load line. Say load line. So if a bipolar junction transistor, for example, 2N2222 NPN bipolar junction transistor, is said to operate as a switch, then the operating point of that transistor will be this point to this point. So this will be the operating point or operating regions, because the switch has to turn on and turn off. So when it turns on, in electronics we call it saturation region. When it turns off, in electronics we call it cutoff region. Okay? Also the same transistor, for example, 2N2222 NPN bipolar junction transistor can be set to work as an amplifier. Joseph Pasco is busy. Then, so if that's the case, in order to set this transistor to work as an amplifier, we have to do something we call it biasing. Okay? So when you do biasing, we have so many possibilities and so many operating points between this point and this point. So it means that these regions, this one and this one, we call them, this is the switching region. And then from here, the remaining part of the graph, this we call the amplification region. Amplification what? Region. So it means whenever you buy a transistor, it can either operate in cutoff region and saturation region, or in amplification region. So how can you set a bipolar junction transistor or a transistor to operate as an amplifier? You have to do something called DC biasing. Say DC biasing. So your operating point can be either this, your operating point can be this one, 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 can be this one. But you have to remember, you as electronics engineer, you have to be careful on choosing the operating point, because if you do a mistake, you can find that the output waveform will not have or will not be a clear sinusoidal signal. as we've introduced in the input. Why? Because there's a part which we call it, there's the part either in the positive half cycle or negative half cycle which will be missing. If you set poor operating of the transistor, you might have these kinds of the waveform of the output. So you might have that this is the positive half cycle, but here you have these kinds of the negative half cycle. And then you have positive half cycle, and then here you can have just these kinds of the, it's not clear sinusoidal signal if you set or you mistake in setting the operating point. So my aim of today, or drawing that graph, is not to explain to you in detail. Yes, I'm trying to remind you some key concepts that we taught you in A-level or ordinary diploma, and we taught you in analog electronics. Shane is communicating. So, if that's the case, what do I want to tell you? From this graph of load line, which we call the output characteristics of the transistor, right? That is output characteristics of NPN common emitter transistor. Because you have input characteristics and also you have output characteristics. Okay? So from this graph, it means that in order to use a transistor as an amplifier, you have to set it to operate in amplification region. That's the first condition. Are we together? If that's the case, in every amplifier circuit, we have a part of that circuit which will be responsible to set that transistor to operate within the amplification region and not the cutoff regions or saturation region. And that circuit, we call it the C biasing unit. That is the first C circuit. Okay? So the C biasing unit for this case actual is this one, voltage divider unit, collector resistor unit, bipolar junction unit, emitter resistor unit, and output, and OT. Yes, these 4 blocks. So 1, 2, 3, 4. Those are the blocks which are dealing with biasing a transistor to operate in amplification region. And we call them, that is the DC biasing system or subsystem. Okay? Okay? The aim of the design to solve a problem, right? The aim of the design is not to set the transistor to operate in amplification region. That is just one of the objectives, right? But the main objective to see that you are introducing the audio signal in that amplifier and being amplified. Okay? So if that's the case, we have also another subsystem within the voltage divider audio amplifier. That second subsystem, that the system we call it, it's a subsystem dealing with amplification of what? Joseph Pasco. Jamani, hebu zingatieni basi ninachowafundisha. Mbona mnasumbua na hao marafiki zako? Sikiliza kwanza, ukitoka hapa utaenda kudiscuss zaidi. Sasa mara unaandika kitu unampa jamaa. Ndio nini sasa? Mwisho wa siku nikupa mtihani, unaanza kulalamika. Kumbe majibu ya huyo mtihani nimeyasema. Wewe uko usikilize. Okay, let us continue. So, if that's the case, what do you say that? We say that we have a second subsystem. Okay? That second subsystem will be dealing with the information signal. Will be dealing with information. So, this block will be dealing with only the information signal. But, however, that it can also do something. But it's not a part of what? Of biasing. Okay? This unity will be dealing with what? Only the information signal. Similarly to this one. We'll be dealing with only information what? Eh? It means that within the voltage divider audio amplifier, we will realize that we have the C signal flowing through it, and also we have AC signal flowing through it. We have the C signal flowing through it for biasing. And also we have a C signal flowing through it to be amplified. Class, are we together? I will sing this song in these kinds of the theoretical. I'll sing this song in simulation. I'll sing these songs in hardware implementation. So you should not worry. I've just introduced to you today. I'll repeat several times until that click in your mind for the rest of your life. Are we together? Yeah. So this block, how does it work? So now I'm going to explain how the DC biasing subsystem works. Okay? We say the DC bias subsystem is this one, this one, this one, this one. First of all, the DC subsystem cannot work without the DC power source. Okay? The DC power source. And the DC power source will get from the linear power supply. Are we together? That's one. Number two, when you supply that power, it will be supplied and it will be supplied into the collector resistor unit and the voltage divider unit. Are we together? So the collector resistor unit will be allow some amount of currents to be drawn through the what? The bipolar junction transistor. Okay? Then this DC signal we supply from the linear power supply unit will be divided by using the voltage divider circuit, which often we are using two resistors. Okay? So when that voltage will be divided, the division of the voltage should be based on the specification of the manufacturer about the maximum base voltage that is required to set that particular transistor to operate in amplification region. Can I repeat? Yes. Can I repeat? Yes. Yes. I said the amount of biasing voltage that is required to be fed into the base of the bipolar junction transistor should be determined according to the manufacturer's data sheet because of the particular transistor. So every transistor has its maximum biasing voltage, or we call it has its maximum base voltage. When you exceed that voltage, the transistor is going to burn. Those are the material we have never taught you in advanced electronic science. What we have taught you, just how to calculate base current, collector current, emitter current. You're expert in that, eh? Current gain. No? Then to show the relationship between current gain of what? Common emitter and common base. Means the relationship between alpha and the beta. You're expert on that. Do you remember those stuff, eh? Yes. Yes. So we say that the aim of this the voltage divider unit is to get the voltage you call it VB, which we are calculating. Okay? We will work on this one, don't worry. This VB, or base voltage, of different transistors is different. Different transistors have different base voltage. Okay? So during your design, you should know the maximum base voltage declared by the manufacturer to set the transistor that you want to use to operate in amplification region. So Lucy is watching her computer. Did you get that idea? Did you get it? Did you get it? Let me repeat. For example, this transistor is manufactured by different manufacturers. Okay? So once you manufacture this transistor, they should prepare something we call the data sheet. Say data sheet. Data sheet gives you all the technical information on how to use the transistor that you want to use. One of the technical information that you have to know or you have to find in the data sheet of 2N2222 is maximum base voltage or maximum base current. You might be given the maximum base voltage or the maximum base current. Right? Why the manufacturer gives you this one? In order to make sure that you don't exceed. Because if you exceed, the transistor is going to burn out. Class, are we together? Yes. Are we together? Yes. So that's why we want you to set the DC voltage from the linear power supply to be the desired base voltage in order to feed into the base of the bipolar junction transistor. Are we together? So that's the function of this voltage divider circuit, to divide the voltage and provide the suitable amounts of voltage to set the transistor into the amplification region without destroying it. Are we together? That biasing voltage is fed to the base terminal of the bipolar junction transistor unit, right? So once we have the base voltage and base current, or we have actually that means that the current or the base voltage, and we also have the collector currents and collector voltage. When we fed them here, then now this transistor is going to be set to operate in amplification region. Are we together? Then the DC signal fed into the transistor here, and the DC signal fed into the transistor through the base will be summed together and will be flowing into the flowing out through the emitter terminal into the what? Emitter resistor unit, and then finally the electric current will go to the ground. Peeling? You are peeling. Did you understand how the DC biasing circuit works? I will repeat this several times until you dream it. Let me repeat lastly. We say that the operation of DC biasing subsystem start when the the second subsystem in this block diagram, we say that the second subsystem, we say it is information amplifying unit. So listen, how does it work? Listen and look. So that part, it always, because the information signal which is going to be amplified is AC in nature. When we say AC, we don't mean that domestic electrical power. We mean that it's alternating in nature. The magnitude of voltage might be maybe 10 millivolts or 20 millivolts. When we say AC, we don't mean 240 volts, right? We mean about the alternating voltage of the low voltage, but might be higher frequency rather than the domestic power. Okay, class? So then that information signal will be fed here into the input decoupling unit. In the input decoupling unit, we always using ceramic capacitor. And the function of that ceramic capacitor, the nature or the functionality of ceramic capacitor, it allows alternating voltage or alternating current to pass through them. Why? Because its capacitive reactance is small, not infinite, like in case that you feed the DC signal. So the function of this input decoupling unit is to allow the information signal to be fed into the voltage divider unit. Another function of input decoupling unit is to block the DC signal from the linear power supply to be fed into the microphone. Okay, I see you are busy with some other things. You don't listen, you don't watch. Especially my friend who have a white t-shirt. Now he's checking his friend who has a pink t-shirt. So, once that information signal is fed into input decoupling, so the input decoupling allows the information signal to pass, at the same time block the DC signal to flow towards the microphone. Okay? So that information signal will be fed into the voltage divider unit, but the voltage divider unit has nothing to do for the information signal. Then that signal, which is information signal, really, it will be fed into the base of the bipolar junction transistor. So the base of the bipolar junction transistor receive or allow the information signal and the DC signal to pass through. Okay? Yes. Okay? Yes. Then, here we have what? The bipolar junction transistor, which is already set to operate in amplification region. Kevin is busy. So, because this has been set to operate in amplification region, then it can amplify the information or the audio signal according to its amplification factor, which we call it the current gain. Are you together? So once that signal is amplified, it will have two routes. The large amount of that signal will be fed into the output coupling unit, and the small amount of that information signal will be fed into the bypassing unit. So listen what happened here. So the function of the output coupling unit is to allow the amplifying signal to be fed to the load or the output unit. Then another function of output coupling unit is to block the DC source from the collector resistor not to flow towards the load or towards the output unit. Okay? Okay? And then I will tell you the reasons. How does this block the DC and how does this block the DC? I will tell you the reason. And that reasons we taught you in ACCOL as one of the subtopic of 40 current electricity in Form 6. The first thing, that's the second topic. The first is electromagnetism. The second is current electricity. Possibly forgot because it's usual for me. Then, here this is the point. This is another unit which is responsible for what information signal. Ever, I want your eyes to focus here. So what is happening? Some information signal will be flowing towards this junction. When it reaches here, because it's AC signal, and here we are going to have a bypass unit. The nature of bypass unit providing low resistance to the AC signal and providing high resistance of the DC signal. Why? Because in this emitter table, we have DC signal from the biasing, and we have also the information signal. When you don't watch. So once this DC signal reaches here, it will be allowed to pass through the emitter resistor unit towards the ground. But that DC signal will not be allowed to pass through the bypass unit towards the ground. A small AC signal, which is the information signal, right, which is delivered at the emitter table of this transistor, will be allowed to pass through the bypass unit. Why? Because the bypass unit providing low resistance against the AC signal. Are we together? Yes. Are we together? Are we together? Yes. So today, just understand that piece of information. Next week, I will explain to you more and more and more. And you know what will happen? You'll become expert in this system. So I explained to you how does block diagrams work. When you have a schematic circuit diagram, you will understand. When I take you to simulation, you will extremely understand. When you go for the hard implementation, you will be understanding in such a way that you want to teach somebody. Are we together? Yes. But the thing that I want to tell you, change your mind. Tell yourself, I don't know. In Excel that I have to know. So that in case the new or the brand new information comes in your mind, it's simple for you to listen. Are we together? So go and wake yourself. Go and wake yourself. Oh, I know the audio amplifier, but I'm missing some information. Are we together? Class, are we together? So once you have that once, we go for 5. What is it? 5. 5 when 20. 5 when 20. When 3. Right? So the 5.3 we say that. So he said that the wall meter, block diagram. The wall meter block diagram of voltage, or let's say that of just the audio amplifier. Audio amplifier. that I say, maybe you don't understand clearly. Don't bother yourself. The only thing which I ask you, be the open-minded, have a fresh mind, have a strong desire to understand, and make sure that you don't miss any class. When I tell you that now we are done to design, then from there you can tell me that I didn't understand. I think that I have to find another way to teach you. Because I have different ways of teaching students. Okay? So today, just to understand the small portion. Today, just I was giving information. Something is hidden there. Okay? That's enough. But maybe you didn't understand what is hidden. But keep coming. Are we together? Yeah? So now we are going to draw the word. Little block diagrams of audio amplifier. So ready? You know how to draw it now. And we have been drawing parts of it. Okay? So ready, let us go together. Let us start presenting our linear power supply. Okay? Yeah? Yes. How many blocks do you have there? 4. The first one is what? It's what? Step down what? Transform. Don't write it because the transformer is just one element. Transform. Then let's see. That's the voice of secondary student. Next is what is Shkuru? Shkuru is not there. Next is what? Last. 85. 85 what? Members? 85 members, eh? Then next thing. Pardon? Filter. Which type of the filter? You forgot. Then next thing. What the function of the body regulator? Voltage regulator unit. We have the output for the regulated units. So here we are going to have the output. So here we have the output. So then I have what the input of our system. What the input of our system? You forgot. Meanwhile, so the input of the block of input of our system is microphone. Okay? The microphone is saying needs certain power. I say, don't it go. Look at it. You have been drawing so many diagrams, you have been writing so many information, but you didn't understand it. Pay your attention, understand, then draw. Where are you running to? You want to run outside of that door? First of all, it's raining. Then we say that, so this is the linear power supply. Okay? Okay? I say, please examine your neighbor, because your neighbor is outside of this class now by accident. So this is what is input coupling unit. The output of the microphone is fed here. Okay? Okay? Then next, we say we have another block. Another block is called what? Voltage divider for this page. Voltage divider. Voltage divider. Then the information signal is very distributed. But at the same time, the function of voltage divider. Which kind of the stories are you making while I'm teaching? Which kind of the stories are you making? My friend again is busy. It's white t-shirt. Sickness. Okay. Then we say that the function of this voltage divider unit is to bias or to divide voltage. Then the next block of the interloop diagrams of the amplifier is what? So the next block, we say that it is, we have another block. It is bipolar junction transistor audio amplifier. Or bipolar junction transistor unit. The outputs of the voltage divider will be fed at the combination. Then we say we have another block here. And this block, we call it collector. Collector resistor. Collector resistor. Resistor unit. Collector resistor. So this one should receive the electricity. Okay? Then you should feed the output to the logic by junction transistor. Okay? Then we say that we are going to have another block here. We should go to church. Outputting coupling. Output churching. Coupling. Okay? Okay? So the output of the bipolar transistor is set to the output coupling. You get finished for the detailed diagrams of audio amplifier? No. We still have some other units. Okay? The next unit is what? Emitter resistor. I believe that you will take a photo of this detail, or all detailed diagrams of audio amplifier, and you put in a status in this video. This is engineer view. This is engineer Sonia. Engineer Zuena. Engineer Zuena at work. So the psychology at work. And then so right there, you know, I know that now, in case you meet with your classmates who are studying at the University of Dar es Salaam, they have so many stories to talk with them. Engineering can be summarized into numbers, formulas for education, diagrams, tables, and the graphs. That's what our lecturers are taught us. How about you? What matter? What did you say? Diagrams. Which diagram? So I know that now we are gathering information to go and show up that I'm a competence-based building engineer. And it's okay. You can explain a lot of things. The issues, can you do them? But you won't go wrong. Explanation is not. Is it? Eh? Yes. Okay. So then another unity, Lativa. It's what you? Bypass. Unit. Then this one get the signal as a division from here. And if you finish for the blocks of audio amplifier, no, what's the name? Then we have another plastic block, which is a symbol. This one we call it node. Node, but in case of our case or our diagram, I think there's still a digital diagram. We call it, let us take let us put speaker. So the load or speaker or anything which are used the amplified signal receive the signal from the output coupling unit. Are we together? Look on the blackboard. How many blocks do you have there? Count with them. Count with the blocks that you have. 13. Where did you get those 13 from? How many blocks of electronics engineering? 4. But do you remember that I told you about an amplifier when I have been teaching about schematic circuit diagram? Do you remember? And you are satisfied with those four blocks. You didn't know that there is a hidden knowledge that I have, which I didn't want to talk that way. Are we together? Do you enjoy? Do you enjoy this stuff? Did you ask your neighbor? Did you enjoy that little block diagram? Did you enjoy? The word literally block diagram. We did not discuss anything about design. We did not discuss anything about schematic. We are going there. So don't miss. We are going to design every electronics component that we have in that schematic circuit diagram from the mathematical point of view. So don't worry. Get in touch. So the whole detailed block diagram of voltage of voltage divider amplifier. What is audio? So you know what I want? I can tell you before you draw. There is no any book, or it is difficult for you to find a book or an article that is drawing this on the audio, on the block diagrams of the audio, the word or the detailed block diagrams of the voltage divider audio amplifier in this year. Most of them they used to draw mainly 4 or 5 blocks. So where did I get this knowledge? I tell you, these are the combinations of knowledge that I've been gathering from one source with another source. So I learned some material here in this source, then I learned some other materials in another source, I learned some materials in another source, then myself I started trying to brainstorm, and finally I come with the whole system. Are we together? Yes. Are we together? Yes. This we used to say that if it is, for example, in the European countries, especially European, America, if somebody teaches you something the other thing, and you see that that person has done it extra, that person has done his or her extremely effort at the basic, you know what they used to do? They appreciate. But in both, forget appreciation. Okay? If you are teaching some students who have learned to appreciate, once they have this, you know what they do? They just congratulate and say thank you. But in Bongoland, forget that. In Bongoland, forget Gila's first, appreciation later. Okay? So anyway, because for me, I appreciate you always, rather than for you to appreciate me. And whether you appreciate me or you don't appreciate is fine. Myself, I appreciate myself. So let me appreciate you. Did you understand what I've done there? Yes. Okay, clap your hand for yourself. So can you explain how these whole detailed block diagrams work? Class, I said don't do anything. You are expert in drawing. You have a number of drawings, but you've never understood them, most of them. Class, I ask you, if I ask you a question, explain step to step how these whole detailed block diagrams of how the amplifier work. Can you? Can you? Where does it start? Where are you going to start to explain? Huh? Huh? Linear power supply. So others say linear power supply. Others, where are you going to start to explain? Huh? From the microphone. Another Idea? For those who say that explain the operations of this whole little block diagram of the audio amplifier from this point, raise up your hand. For those who will say that if I'm given a chance to explain how does this block diagram operate, I will start from the microphone. Raise up your hand. Raise up your hand. Shukuru, I'm talking to you. And Nixon. So the rest, because I so feel serious. Who was your hands for case of here? The rest, what do you think? Where are you going to start explaining? Oh, no idea. No idea. No idea. Class, I'm talking to you. No idea. Oh, what does it mean for the rest? For instance, that is microphone. Yes, sir. Microphone. Johanna, leave the power supply. Sonia, from the microphone. Pasco, from the linear power supply. Eva, Alpino, linear power supply. National, supply. We don't have supply there. We don't have supply. David, where are you going to start explaining that block diagram? You are smiling. Is that your whole voice? Linear power supply. So where are you going to start from the linear power supply? Freddy, Harold, from the microphone. Emmanuel, just mention the block. Which block are you going to start explaining? Harold, second and so. But first you say microphone. You check your idea. Nambua. Mention the block which you will start explaining. Don't tell me linear power supplies me with that. Just mention the name of the block. Don't give me block politics. Grace. Your name is Grace. Oh, what's your name? Anastasia. Anastasia. Pardon? Sit down. Transform. Angelina. Sit down, transform. I am Bunye Suleiman. Sit down. Benjamin. Sit down, transform. Why sit down, transform? Gracious. Gracious is coming back to the class because she's doing that. Gracious. Buena. Buena also is outside the class. Howard. Which block will you start explaining about the operation? Sit down. Have you said Pastor? Microphone. Bryson. Transform. We have transformer there. That's great. Glory. Microphone. Salama. Microphone. Gaudens. Microphone. Eliakimu. Mimi, who is growing? No idea. Okay. Engineers, I told you that. Whenever we draw, so stop writing and stop drawing. What I'm telling you is expensive more than you think. You know, sometimes that I might come with a very good information to teach you, but the way you receive you are actually out of the discipline, most of you. I think that you have to learn how to be disciplined in class and to keep focus. Because when you've been told you, listen, listen. Draw, draw. Stop, stop. Simple like that. Are we together? Yes. Are we together? Yes. That is an assignment which I'm giving you before we meet next week. Because next week, when I realize that you are not disciplined, I will take you out of the class. Because most of you, you don't know the value of what I'm teaching. You don't know the value yet until you get into maybe the second year or the third year, when you see the kind of education that you are going to earn during your 4 years. Then that's the time when you realize that, that person was teaching me valuable stuff. But then you cannot come back, the time has already gone. Because this is the only year, which is fresh year, to prepare yourself to become competent in electronics and communication design. Once you go to the second year, you will never have time. You'll be having many projects, go and find it. You are just designing something, or you be just paying somebody to build that project, and then it's not working. So when you miss this year and you get to the second year, you don't have the fundamentals. Forget the fundamentals of electronics and communication for the rest of life. Are we together? Are we together? Yes. Okay. So keep reading and listening, because next week I will take you out in order to go and learn how to be disciplined in there. Because I'm using a lot of energy just to put you in position. So I want to do the same next time. Okay? Yes. Okay? Yes. Okay? Yes. And I don't mean that all of you are undisciplined. Some of you are very and extremely disciplined. But some of it is disaster. Because for you, you cannot see them. You are all the times you are looking for me, right? I'm the one who is seeing you. Are we together? Can you imagine if I come in the class and then I be undisciplined? Will you be happy? No. Will you be happy? No. So if you are not disciplined, because learning is just a matter of discipline. If you are undisciplined, it means that you are not prepared for that day to learn. I will warn you once. If you do for the second time, then I just you. The intruder is different. Okay. Listen. I told you the principle or the working principle of any electronic diagram should always start from left to right. I told you that don't think about the control unit while you don't have the input unit. Don't think about the output unit while you don't have the input unit. I told you just to pray. And don't think about the operations of the input unit or control unit or output unit while you don't have power. Get through that stand up. Didn't I teach you those stuff? Eh? Yes. I say, just 3 sentences. Don't think about control unit before you think about the input unit. Don't think about output unit before you think about your input unit. And don't think about operations of either input unit or control unit or output unit before thinking about the power supply. If I could be you, I would not teach those things, because I have taught you in the same class just a month ago. Now you don't remind me. So if you look at the principle, this is the input unit. This is what because this is the business we are doing annually, we are doing year after year. We know the way that the students, even ourselves, we find that we are learning. We have to be serious. You cannot relax when you are learning something. You end on sleeping. Are we together? Yeah. Okay. Okay. So this is our input unit. This is our control unit. This is our power supply unit. This is our output unit. Remember the three principles. If you didn't write, I allow you to write today. Are you ready to write? Because you are good in writing. That's an input in your mind. I said that. Don't think about operation of the control unit without thinking about the operations of the input unit first. That's number one. Don't think about the operations of the output unit without thinking about the operations of the input unit. Don't think about the operations of the same principle. Don't think about the operations of the input unit and control unit and the output unit. And don't thinking about the operations of the power supply. Did you write? Okay, right. Will you remember? Write it. Write it down. So others they are praying. Olenjolain, repeat. Let me repeat. Don't think about the control unit without thinking about the input unit first. That's this enough. The second principle. Don't think about the output unit without thinking about the input unit. You are not writing, eh? Good. The second principle. Don't think about operation of input unit, control unit, and output unit without thinking about the operations of the power supply. You need me to repeat? Huh? You need me to repeat? Yes, let me repeat. Because I laugh. Hey, just stop there. I'm about to finish. Stop there. It's just a matter of time. I say that I'm about to finish. So the first principle, don't think about jotting. Control unit, just think about jotting. Input unit. The second sentence, don't think about output unit, don't think about jotting. The third principle, don't think about don't think about operation of what? Input unity, control unity, and output unity without thinking about operations of what? Power supply. Those three principles will change your way of learning electronics and telecommunications. So now we come to the point. So if you be given a task to explain how does this block diagrams operate, it's simple. The first point that you have to start is power supply. Because without power, the microphone will not work. Without power, the control will not work. Without power, the load will not work. Okay? So you have to explain about what will be the input through the step-down transformer, what is happening here, then what will be happening here, what will be happening here, my friend is chat. What will be happening here, and then here you have a power. So it means if this works effectively, here we have power, we have power. So you come to the part of the circuit. I say this so writing. Let me repeat. To explain the operations of this wall detailed block diagram, you have to start from the step down. What will the step downs do to the input power? Then explains the function of this. Then explains the function of this. Then explains the function of this one. Okay? What is saying and what will be the output. Then now, all the other three units will have power. Inputting, controlling it, and output. So when the power supply is there, you come and start explaining about input first. What does it receive at the first sequence? What does the microphone receive? Right? And then what does it do for the receiving information? Once it is finished, you explain the function or the effect of this block, this one, then this one, then come this one, come to this one, come to this one, come to this one. Finally, you finish your sort. But if we go, you know what we do? We don't worry about this on supply. We don't worry about the input. We don't worry about what happened. We come here to measure the air. We come here to measure the air. And in most cases, we take what your slow to check to see what the amplified signal. While we don't have that, the input signal. Or while maybe the control is not working effectively. So we are always people who ask what output. We don't watch input. And they gave me a simple example in case of our traffic. Listen, they are getting something without weight from the conductors or drivers. Class, are we together? Is it clear? Did you understand? Okay, so now it's a time to congratulate you. Relax. Be happy. We are about to finish. Be happy. So 1, 2, 3, let us go. Ongera. Imara. Wow. So this is the end of workshop 2. I would like to thank God who have taught me how to teach you. I would like to pray God to make sure that He will give you a chance to be together in workshop 3, where that I will continue from the point where we ended. And lecture 3 will go for the design. We'll be designing about this linear power supply. And I'm going to talk more technically, more than what you know. Okay? So, don't miss the next workshop. Thank you very much. I thank God who have given me a chance to be a part of this class. But take all of this information. Make sure that you work with those simulation tools that I taught you in this weekend. And if it will be possible, start to draw your schematic diagrams of the 10 instruments that you chose in this weekend. Are we together? We are not limited. We have the simulation software. We have already simulated possibly about the turning on and turning off the light emitting diode. So then now we can go further to simulate the schematic circuit of the product that you say that is working. Are we together? So for the online community, this is the end of our class. And thank you very much. In case that you have any question, don't hesitate to ask me. And then see you in the next lecture. This is Olenjolain. I love you so much. Keep enjoying electronic telecommunication engineering.